Stay tuned to understand the magnetic effect on a wire carrying current through a magnetic field. Hello everyone and welcome to a new video. In this video we will be explaining the magnetic force on a wire. Charges moving through a uniform magnetic field will experience a force or a magnetic force acting on it, and we learned that from the previous videos. Now, what if these charges were trapped inside of a wire as a current? Because we know that current is the number of charges passing each second. So this means that the wire will also experience a force acting on it. So the whole idea is that magnetic fields have effect on charges, and charges are passing through wires when there's current passing through a wire. This means that the wire will also experience a force applying on it. This magnetic force is pretty easy to find. The force is equal to I multiplied by L multiplied by B. I stands for the current, and L stands for the length of the wire, and finally B stands for the magnetic field strength. So the force will be equal to the current multiplied by the length multiplied by the magnetic field strength. So it's pretty easy to find the magnitude of this force. But we know that every force must have a direction. So to understand the direction, we will be using again the right hand rule. How will we be using the right hand rule? It is pretty easy and straightforward. Let's use a right hand here. To use the right hand rule to find the direction of a force acting on a current carrying wire, we will do the following. First of all, we will make our fingers point towards the magnetic field. As you can see, the magnetic field is going to the right, so my fingers are also pointing to the right. Next step, that I will make my thumb go towards the direction of the current. So look here, my thumb is at this side and it's pointing in the direction of the current. Finally, the force will be in the direction of the palm of my hand, so it's going downward. So it's pretty easy. Once again, the right hand rule. Yes, we will be using right hand rule again to determine the direction of the magnetic force. Again, do not forget to use your right hand, not your left hand. My thumb points towards the direction of the current. My fingers will point in the direction of the magnetic field. Finally, the force will be in the direction of the palm of your hand. So it's pretty easy and pretty straightforward and direct. So let's go directly and solve some problems. Question number 1. It says that a loop of wire shaped into a triangle carries a current of 2 amperes in the direction shown. Now, a magnetic field of 6 teslas is directed into the paper. So the X means that the direction of the magnetic field is going into the paper. What are the magnitude and the direction of the force applied by the magnetic field to the 5-meter edge of the triangle? So we have 3 edges. It's asking about the force on the 5-meter edge of the triangle. So first of all, we will be using the right hand rule again to determine the direction of the force. The hand will be pointing towards the magnetic field, or sorry, the fingers will be pointing towards the magnetic field. As we can see, the magnetic field is going inside the paper. Now, my thumb will be pointing towards the current. So this is my thumb, to make it clear. It's pointing towards the direction of the current, okay? So it's going this way. The current is going this way. It's going in a diagonal way. Now, finally, the force will be in the direction of the palm of my hand. So this is the palm of my hand. As you can see, my finger is pointing towards the current. As you can see, my thumb is pointing towards the current. Let's just fix this a little bit. Again, my fingers are pointing towards the magnetic field. My thumb is pointing towards the direction of the current. Finally, the palm of my hand is showing me the direction of the force. So the direction of this force, in this case, is going this way. So the choices that show the correct direction are A and D. But what about the magnitude? We know that simply the magnitude force F is equal to the current multiplied by the length of the wire multiplied by the magnetic field. So it's simply 2 multiplied by 6 multiplied by the length of the wire, which is 5, the answer is going to be 60, and the correct answer in this case will be A because it shows the correct magnitude and the correct direction. Next question. The force that two straight parallel current carrying wire segments exert on each other depends on the following. Number one, currents in the two wires. Number two, length of the wires. Number three, the distance between the wires. So I think that it's clear that the answer is D. Why is that? Because the current affects the magnetic field. Higher current means higher magnetic field. So higher magnetic field will increase the force acting on these wires. Second of all, length of the wire. It's clear that if I have two short wires and I have two long wires, the force between the short wires is going to be a small force, but the force between the long wires is going to be a large force. So that's clear too. And finally, the distance between the wires. It's clear that if the wires are close to each other, the force will be strong, but if the wires are far away from each other, the force will be weak. So the answer is 1, 2, and 3. The answer is D. Now, I hope this makes this topic a little bit more clear. Stay tuned in the next videos. We will be solving more problems and introducing more topics. See you then.